In this video, we are doing parallel RLC circuits, and this is our AC signal, our source, our voltage, and these coming down are parallel branches. So what happens in a parallel RLC circuit is that the current total is then split into each branch, meaning that the current is not the same throughout the circuit as it is in an RLC series circuit. So in the parallel circuit, it is the current is splitting. So do note that the current is not the same throughout the circuit. It goes down each branch, the current splits, and then it joins up again to become I total. So what is the same in a parallel RLC circuit is the voltage in each branch. So the voltage across the resistor will be 48 volts. The voltage across the inductor will be 48 volts. And the voltage across the capacitor will also be 48 volts. And so this means we can then calculate the current in the branches. If we say V over R will give us the current. Okay, so in this case, the currents are given. So we're going to answer the questions that follow. So the first question in this given question, it's saying the total current. So the total current, we have to know the formulas that are used. There will be a formula sheet. So remember, I total is equal to, so that's the formula that we're looking for. So in the question, we must always look to see which value is bigger, the IC or the IL. It'll always be the bigger one minus the smaller one. So notice here in this case, IC is larger. So IC comes first. And we're always subtracting the difference between those currents. Okay. And then we square it. So this is Pythagoras theorem. This is how you're going to remember the formula. So it's IR squared plus the difference of the currents in the branches. Substituting into the formula, remember that IL is 0.71 and IC is 0.71 and IL is 0.51 and R is 0.48. Notice that not each value is squared, but the reactive current. So reactive current is IC minus IL. Now some questions ask for the reactive current first. In many question papers, the children do not answer this question. They do not answer the reactive current if it's asked. So reactive current is practically IC minus IL. Then in the next step, you're just going to take that value and substitute it where the bracket is. Right, where the bracket is underlined in red. So in other words, it would ask you to first work out the reactive current. Then you're going to take that number, that answer, and substitute it where the underlined red is and square it. And that's practically what you're going to do. So please note that the reactive current is IC minus IL or IL minus IC, whichever is larger. And our answer here on our calculator for this one is 0.52 amps. That is I total. The next question says, calculate the phase angle. Okay, so phase angle, how we get the phase angle? We first have to get the cos theta, which is the power factor. Okay. So power factor is equal to R over Z normally, but in a parallel circuit, we can also use the current of R and the current of Z. Okay, so the current of Z in effect is I total, because if you got the total impedance, you then have the total current. And so IT is more fitting. And so we're going to use the voltage total, which you can see was 48 volts. And we're going to put that over the total current, which we just calculated. So substituting 48 and 0.52 cos, that was cos theta, which is the power factor. Then go theta equals cos to the minus 1 48 over 0.52 in brackets, and our answer there is 22.62. Don't forget the degree sign, and do note that that is what is the phase angle. So this one that we calculated was 342. And the next question says the inductive reactance, 343. Now here with the inductive reactance, do note that the voltage is the same in all the branches. Okay, so the voltage drop across each component is the same. So it's very easy to calculate the reactances here. Okay, so all you have to do is say XL is equal to VT over IL. And so looking at your voltage total, it's 48 volts, and the current flowing through your inductor is 0.51. Punching that into our calculator, we get 94.12 ohms. So do note in this question, there's no frequency given. And the next question is saying supply frequency of the circuit. So do note that next door to the AC signal, there's normally a frequency given. So many hertz, for example, that's the frequency. But in this question, it's not given. So you're going to need to look for a formula where there's F in it and all the other knowns are there. So you can only have one unknown, in other words. So look for a formula on the formula sheet whereby only F is what you don't have. And then you can use that formula to find F. Okay, so the supply frequency. So do note in this question, we have the value of the inductor. We have the XL, which we just calculated. 2 and pi are both known. The only one that we don't have here is F. Dividing everything by 2 pi L on both sides of that equation. So dividing the left-hand side and the right-hand side by 2 pi L, you would only have F remaining. So F is equal to XL over 2 pi L. Manipulating the formula, substitute your XL and your L. Where's your L? Your L's on the diagram in the inductive branch, and it's 0.3 henries. And so the frequency, punching it into our calculator, you'll get an answer of 49.93 hertz. Also remember to study what is millihenries, microhenries, etc. Okay, do go to the book and look all that up. Milli is times 10 to the minus 3, and micro is times 10 to the minus 6. Okay, in the second question, we have another parallel RLC circuit. Do note that the current splits in the branches and the voltage across each component is the same. Do remember that for parallel circuits. They are different from series circuits. Series circuits have the same current throughout the circuit, whereas here the current is splitting, but the voltage is the same across each component. Do remember that. Right, so the first question says, calculate the total current. So we know that IT is equal to the same as the first one. Remembering always to use the bigger branch currents first. So in the question, you can see that the biggest one here will be IC. So IC being the larger, then let's substitute those values. So IR is 2.5, IC is 6, and IL 3.6. Do note that there's subtraction in the brackets. Always subtraction in the brackets and plus in between. Remember that. And there's a formula sheet. Right, so plugging that in, we get 3.47 amps. In the next question, they want the value of the resistor, which is R. And so R is equal to VR over IR. Right, so the voltages are the same in every branch. Alright, it is the current that splits. So R is equal to V over I, in other words. But we are looking at the values of the resistor in that branch where the resistor is. Now the supply voltage is 240 and across each branch will also be 240. So 240 divided by the current that's flowing through the resistor, which is 2,5, we get an answer there of 96 ohms. Do remember to use the correct units. If you have the wrong unit, you will lose that mark. In the next question, they want us to calculate the inductance of the coil. That will be XL. So you know that XL is equal to V over I. Okay, so V over I. So XL is like a resistance, okay, but it's called a reactance. So XL is like a resistance. We know from Ohm's law, R is equal to VI. But we're not going to use R. We're going to say XL is equal to V over I. But notice that we are finding out the value of the reactance of the inductor, which means L. So in the diagram, you're going to look for the IL, okay, because that's what you're dealing with. So notice this will be the inductor. In other words, the coil, the curly one. And there, our values are 240, which is the value across the inductor, and the current flowing through the inductive branch will be 3,6 amps. So substituting our values, punching into the calculator, we get 66,67 ohms. The next question wants us to calculate the impedance, which is Z. Right, so to calculate the impedance, very easy. It's voltage total divided by I total. Okay, so the total current that's flowing through the circuit, V total over I total. Do notice that our supply voltage is 240 volts and our total current, which is given in the circuit, or is it given? No, not given, which means we're going to have to work that out. And I was looking at the question paper, forgot to look at the board. Okay, hard to do this in the dark. But anyway, there we go. We worked that out in actually question 1, and there's the current there. 3,47 was I total, calculated in question 1. And so our answer there will be 69,16 ohms. In the next question, the question is a bit different. They've given the phasor diagram, okay? But they did give us the values on that phasor diagram, so it's not difficult. So all they're doing, instead of them giving us the parallel RLC circuit diagram, they gave us the phasor diagram. So don't be phased by that. All you have to do is take the values, draw your own circuit if you want, and you can still carry on. Okay, so start your diagram like that: a resistor, an inductor, and a capacitor in parallel. And then all you have to do is write the values. So V total is 110, IL is equal to 9 amps, and IC is equal to 7 amps. And then the current flowing through the resistor, that will be IR, is equal to 11 amps. And our first question is calculate the total current. Do you see it's kind of the same thing? So in this case, notice that the IL is larger and not IC. So this is why I wrote IL minus IC. So do substitute all the values there on the screen, plug it in, get the answer, see if you can do it. So substituting 11 squared plus 9 minus 7 will give us 2 squared. We're going to get root something on a calculator. Don't forget to press ST and do right amps. 11,18 amps. Then the next one wants the power factor. Calculate the power factor. Power factor is equal to IR over IT. Substituting our value of IR, we can see on the screen it's 11 and IT being 110. So 11 divided by 11,18, which we just calculated IT above. I said VT by mistake. Right. Plugging it into our calculator, we'll get 11 divided by 11,18. That gives us an answer of 0,98. Notice that power factor doesn't have a unit. Because we're dividing current over current, the currents are going to cancel. If you're using cos theta equals R over Z, then the resistance cancels with the impedance, ohms, and so it doesn't have a unit. So the next question wants the total power. Right, so total P. Why did I put P? Because it's the true power. Because remember, when we use cos theta, it is the true power. Now, please don't go and use root 3 VI cos theta. Please don't do that. Right, remember that this is single phase power, single phase, and so you're going to use a VI cos theta. Right, so the question said calculate the total power of the circuit. This means you're going to have to use a total current and a total voltage. And because it's cos theta, this means it's a true power. So substituting our total voltage, which you can see on the screen, is 110 volts. And then we're going to substitute our total current, which we calculated in number 1, 11,18 amps, times our power factor of 0,98, we get a final answer of 1205,20 watts. Dividing that by 1000, we'll get 1,21 kilowatts. The next question says, state with a reason whether the circuit has a leading or a lagging power factor. The simple way to remember it, that when L is larger, it lags. Always remember it like this. If L is larger, be it series or parallel, when L is larger, the current through L or the reactance of L, if L is larger, it lags. Just remember it like that. So in this question, it will be lagging, because do note here that IL is larger than IC. IL on the right hand side, top right, IL is 9 amps. So that means the current flowing through the inductor is larger. Okay, so IL being larger, this means it's going to lag. So answer here is lagging, and our reason, IL is more than IC. Okay, and here's a mathematical way of writing it. IL more than IC, or you can write IL is greater than IC, in case you don't understand that symbol with the mouth and the arrow. Okay. Okay, looking at the next question, they said that the resistance is 25 ohms, the reactance of the inductor is 26,52 ohms, the XC, the reactance of the capacitor, is 31,83 ohms, and the voltage supplied, or voltage total, is 220 volts. The frequency is 50 hertz. Okay, so this question's a little different. So here they're saying the current flowing through the resistor. Okay, the current flowing through the resistor. So current is equal to V over R, Ohm's law, and the voltage supplied is 220, and the resistor in the circuit, notice there, is 25 ohms. So that's going to be very simple, 220 divided by 25. So plugging that into our calculator, we get 8,8 amps. The next question says the current flowing through the inductor. Okay, so notice that the voltages are the same. So current flowing through the inductor is very similar to 341. It's the voltage over XL. Substitute your values. We know that the voltage is 220 and XL is 26,52. Plugging that in, we get an answer there of 6,9 amps. The next question says the current flowing through the capacitor. So these questions are very simple, all 2 marks each. So IC is equal to V over XC. Our values there, the voltage is 220 again, and 31,83 is our XC. We get 6,9 amps. You know what? I punched in the wrong thing in the previous question. I was supposed to punch in the value of XL, which is 26,52. I punched in 31,83. I'm getting mixed up with the questions. Right, do that one again. 342. Just check it out on your calculator. I get 8,295 on my calculator. So that will be 8,30 amps. Okay. Then the next question, there's that question I was talking about in the previous, I think the very first one I did. The next question says the reactive current. Now this one stumps all the children. Okay, all the learners get stumped here. The reactive current. So remember, reactive current means X. Now they can also ask this in parallel RLC circuits, but they will say calculate the reactance. Okay, calculate the reactance. That means it's going to be X is equal to XL minus XC, or X is equal to XC minus XL. You get the point. That is reactance. Calculate the reactance. Now notice here they're saying the reactance current, the reactive current. You with me? So now it's IX is equal to. Then you look at two of your reactance currents, which will be IL and IC. Look which one is larger and place that one first. In this case, IL is larger. And then substituting the values. So notice that IL is 8,3 and IC is 6,9. So substituting them, and we get an answer there of 1,4 amps. Now the next question says the value of the capacitor. So this one is kind of challenging for the learners as well, the value of the capacitor. So these last two questions, please restudy these last two questions. This is the one that everyone gets wrong, okay? Okay, so the value of the capacitor, that's the formula. Xc is equal to 1 over 2 pi Fc. C, you need to make subject to the formula. So easy to do, so easy to do, okay? All you do, you swap those two around. C and Xc, swap them out. Right, pause the video, substitute all the values, and you'll see how easy that question is. Okay, so here we're going to substitute Xc in the denominator. 2 pi, what is the frequency here? The frequency is 50. Do note that Xc is given in the question, so there's no need to go and calculate it, right? It's there. Substituting all of that into your calculator, you should get around about 100 microfarads. So this is the answer that I get on my calculator. Then you're going to need to move the comma, okay, 6 places to the right so that you can write this in microfarads, okay? So at the moment, this is in farads. So moving the comma 6 places to the right, because times 10 to the minus 6, do you get the idea? So this is 100,031 microfarads. Okay, and we round off always to 2 decimal places. And that's how you'll find the value of C. Quite simple, don't you think? Right, going on to the next question. It says draw the phasor diagram for the following circuits here, for the following waveforms. Okay. Draw the phasor diagram for figures 351 and 352 below in the book. Right, so you're going to draw this one. Right, so notice here, they're both starting at the same time. So the voltage and the current are starting at exactly the same time. This means they're going to be in phase. We also learned something called resonance. So we said with resonance, if you're drawing phasor diagrams, it's a straight line. This is in the textbook. But do note that the voltage is greater. Okay, so the voltage will be a longer phasor and the currents will be a shorter phasor. But they are exactly on top of each other. The other word for phasor is vector. Okay, so drawing that, it's very simple. Okay, VR is longer and the I is shorter. Okay, the rotation is always anti-clockwise. You must include the direction of rotation. Looking at the next question, 352. Notice here, they're not in phase. This is the VC and there is the other wave over here. Now looking at it, you might think that this one is lagging, okay, because it's at 0 and that one is at a higher number. No, what you must do is continue with the wave, continue the sine graph. That means the sine graph would be starting somewhere around here. Do you see it? the sine graph is here. So in effect, it will be 90 degrees ahead of this one starting at 0. So notice that VC starts at 0. So if I continue with this wave and draw it into the negative region, you know, of a, if I can call it a trig graph, right? So normally we start at 0. So if you look at negative 90 degrees, that this wave would be continuing here, meaning which one is starting first? This wave is starting at negative 90, then this one only starts at 0. So which one is actually leading? Notice that this one is leading, right? So drawing that, the VC is definitely lagging. So notice that VC will be going down. So VC is going down, okay? And there is the current there. So do notice that it's 90 degrees lagging. Direction of rotation is this way, which means that VC is 90 degrees behind the current. Do you see it? Let's go back there. Can you see current here? I. Okay, can you see I listed there? I. Okay, so do notice in this one here that this is the current and this is VC. So VC is starting at 0. Notice that this one is continuing all the way to there, which means the current is 90 degrees ahead of VC. So coming back to the diagram, do notice that the current is 90 degrees before VC because the rotation is this way, meaning the current is first, the voltage is following 90 degrees later, the voltage of the capacitor. Right, I do hope these videos were helpful. All the best.